Hey, Professor Sargent here with you again. And we have just seen that logarithms are the inverse functions of exponential functions. We have to have the same base. The base has to be positive and not equal to 1 because of the connection of logarithms to exponents. Some properties that we know about exponents transfer over to some properties of logarithms. We're going to learn about, say, 3 of them that are very important. They are the product rule, the quotient rule, and the power rule. We're going to look at about 8 examples where we talk about either splitting up a complicated logarithm into sums and differences or multiples of logarithms, or putting them back together into a single logarithm. Got about 8 examples coming up for you, so get ready. Join me.
All right, let's check out some exercises that involve using properties of logarithms. This first one, with 2 parts, we're supposed to use the product rule for logarithms to rewrite as a sum of logarithms. So, on this first one, that would give us the log of 3 in base 2 plus the log of 6 in base 2. That's the answer that we're looking for. But if you would like to feel more confident about your answer, then if you know about the change of base formula, we could see how close this is to the original. 3 times 6 is 18. Remember that the answer to a logarithm is an exponent. So what power of 2 could give us 18? 2 to the 4th is 16, and 2 to the 5th is 32. So I'm expecting an answer that's between 4 and 5. So let's see here. Log of 18 divided by the log of the old base. Notice how I'm keeping both of these in base 10. You could instead do natural log for both top and bottom. We're getting 4.1699 something. Whereas if I put the log of 3 divided by the log of the old base 2 plus the log of 6 divided by the log of the old base 2, we may get exactly the same decimal approximation, or we may get something really, really close. There may be some round off error. In this case, it's coming out exactly the same. And what I have written here, that's the answer that we're looking for. Why bother with something like that? Well, calculators, as powerful as they are, and computers as powerful as they are still with limitations. So you could be looking for the logarithm of some huge number that the calculator can't take the logarithm of, but if you can break it down into either a product of smaller things that it can handle, or even better yet, do the prime factorization and write it with exponents, even better. Also, knowing the product rule, allowing us to rewrite as a sum of logarithms, will let us rewrite formulas. So on the next one, log of 12 times 16 in base 4, I'm going to split that up as the log of 12 in base 4 plus the log of 16 in base 4. Now this one we can go a little bit further. You may or may not have to on your online homework system. There's no nice integer power of 4 that would give you 12, but since 4 squared is 16, you may need to rewrite this as the log of 12 base 4 and then plus 2. Now in part 2, we're supposed to rewrite using the quotient rule for logarithms to rewrite as a difference of logarithms. Log of 5/8 base 4, and when writing the difference, just like the order of division matters, the order of subtraction is going to matter. So we're going to have log of 5 base 4 minus the log of 8 in base 4. And you can do the same thing I did in 1A to check on the calculator if you would like to feel more confident in your answer. So now what's this power rule? Well, actually in 3A, it's not quite the power rule. but there's something related. We've got the log of 5 in base 3, and 3 is being raised to that power. Y equals 3 to the x and y equals log of x base 3, those are inverse functions. And so they're going to cancel each other out. So our answer here is just 5. On the next one, it's a little more complicated, but the order of logarithm versus exponential is reverse, number 1, and number 2, we don't have the same base. The exponential is in base 6, but the logarithm is in base 5. The idea here is that we can still bring out the exponent in front as like a coefficient or a factor to multiply. So that's going to be 2 times the log of 6 base 5. And if you would like to check that on the calculator, well, 6 squared is 36. So let's use the change of base, log of 36 base 5. So log of 36 divided by the log of the old base 5. And we're getting something between 2 and 3, something we might have expected. Whereas if we do 2 times the log of just 6 divided by the log of the old base 5, here again, it looks like it's giving us exactly the same thing. But don't be surprised if you try this sometimes and they don't exactly agree. It's just a little bit of round off error, most likely. Now we're supposed to split up something with variables in there. We're assuming that all the variables are positive. We're not supposed to leave any powers inside the logarithm. Well, doing this is kind of like reversing the order of operations. I'm going to deal with the multiplication and division first, and then the power last. So let's see here. We would have the log in base 11 of the product of x to the 1/2 times y to the 1/3 minus the log in base 11 of t to the 4th. Minus the log of t to the 4th in base 11. Now, right now, on that part being subtracted, we could go ahead and apply the power rule right now. But first, I'm going to split up the multiplication as a sum of logarithms. So log of x to the 1/2 in base 11 plus the log of y to the 1/3 in base 11 and minus the log of t to the 4th in base 11. Now apply that power rule. 1/2 out in front of the log of x in base 11 plus 1/3 out in front of the log of y in base 11 and minus 4 out in front of the log of t in base 11. So on this next one, we have to be a little more careful even still. Think about the fact that this is like we're reversing the order of operations. First off, let's see here. Things with radicals, we're going to want to rewrite 4th root of 2 as 2 to the 1/4. And then that's all over the s cubed t. When we split up the division, still have that whole product as part of what's being subtracted. So that's going to be minus the log of s cubed times t in base 4. So the thing to be careful about here is that when we split up that multiplication, that whole thing was being subtracted. So the log of 2 to the 1/4 in base 4 minus, well, there's going to be parentheses around this whole thing, the log of s cubed base 4 plus the log of t in base 4. I'm going to put two steps together at once, although we should be really careful. I'm going to distribute that subtraction as well as apply the power rule. So we're going to have 1/4 of the log of 2 in base 4 minus 3 times the log of s in base 4. But because I've distributed that subtraction, minus the log of t in base 4. As mentioned in a previous video, splitting up a single logarithm into separate logarithms is like reversing the order of operations. I'm going to rewrite the fifth root of 5 as 3 to the 1/5, but I'm going to wind up making use of that towards the end. First, splitting up the division into a difference of logarithms in base 5. Then splitting up the multiplication as a sum of logs, but that whole thing is being subtracted. So I'm going to have parentheses around the sum of logs. Distribute that subtraction. And then finally, bring out the exponents in front as if they are coefficients. That's the order things have to go in, and we have to watch out for that subtraction being distributed. On this next one, we're supposed to put things back together. If I was talking about in number 4, reversing the order of operations to break things up, then here basically we're going to be going, at least roughly, according to the order of operations. So two times the log of 4 in base A minus 5 times the log of 6 in base A. And we're supposed to assume that whatever that base is, it's some positive number, so that it's some acceptable base. So that should be an equal sign in case that's not showing up. I'm going to apply the power rule. Bring that coefficient or factor in. So that we've got the log of 4 squared in that unknown base of A, and that we've got the log of 6 to the 5th in that unknown base of A. Because that's subtraction, then I can put that back together as a single logarithm with division in it, where the part that's going to be subtracted shows up in the denominator. That may be all that's being looked for in your online homework system, but just in case, oh, can't forget to put that it's in that unknown base of a. They figure out the 4 squared is 16, and 6 to the 5th. Let's see. $7,776. 7,776. Now that can be reduced. They might even expect that. I'm not sure. Oops. At the very least, we could divide top and bottom by 2. Looks like we can actually divide top and bottom by 16 to get the logarithm in that unknown base of 1 over 486. Base A. And for this last one, without using a calculator, if the log of 2 in base 10 is 0.3010, and the log of 49 in base 10 is 1.6902, let me do a little erasing so I can read that for sure. Yep, 1.6902. Then evaluate log of 196 in base 10. Well, since that's even, definitely 2 will go into 196. I think 4 will. It does, 49 times. And then writes the 4 as 2 squared. Then this is back to splitting it up. So to get this. And from here, okay, they say not to use a calculator, but really they mean don't just do log of 196 in base 10, which just about any calculator that's scientific would be able to do. But, okay, so 2 times the 0.3010 plus, let's see, the log of 49 in base 10 was 1.6902. So this is not a difficult multiplication to do, relatively speaking. But you can check me on a calculator here. Let's see, 0 plus 2, 2 plus 0, 0 plus 9, 6 plus 6, 2 with a 1 to carry. Change, as somebody call it, 0 plus 1 is 1, carrying that 1. 2.922. I am going to check this. Log of 196. It's going to give us something more exact. Getting 2.922 followed by 56071. So looks like I did it right. And that's all for now.
And that's all I've got. Hope it helps. See you in class.